Well, hello there, everyone. What a dang minute. Is this thing recording? Oh, it is. Fantastic. All right. Just wanted to make sure we were recording here. Sorry, y'all. As you can tell, I'm out here just doing my best for y'all, doing this video recording here for y'all, working my tush off while I'm out here quarantined at home. But never fear, Miss Passmore is here. So I'm going to try and make this video not 500 years long, but you know how I am. And let's get started. I'm just going to make this like a lesson that we're working through together. So this would be your warm-up. I would like you to convert the two values on the left from degrees to radians or radians to degrees, and then we're going to evaluate the three values on the right. So if we're going to convert this 150 to degrees or radians, well, first of all, it's in degrees right now, so we're going to need to cancel out the degrees, which means 180 degrees needs to go on the bottom. And then pi goes on top. Now, you might be a master and already know that 150 degrees, based on our memorization of the unit circle, is 5 pi over 6. But if you forget, you'll have 150 pi over 180. You can cancel that. 15 over 18 reduces to 5 pi. 5 and then pi, and then the bottom becomes 6. So voila, we've got that. Next, we need to convert 11 pi over 6 to degrees. It's currently in radians. We know it's in radians because it has pi. Remember, pi is the same thing as 180. We're always using the fact that pi is equal to 180 degrees. So that's why we're going to put the pi on the bottom, because we need to go from radians to degrees. 180 degrees is going to be on the top. And if we're working with that, you can literally just let your calculator do the work here. That would be 11 times 180 all over 6. And if you multiply those together, you don't have to do this, 1980 over 6. And that reduces to 330 degrees. You also, based on your knowledge of the unit circle, remember that 11 pi over 6 is in quadrant 3. And it's the almost last, before 360, that's the last one. So before 360 degrees, that one is 330. And would you look at that? The math works out. Now, for sine, cosine, and tangent of 4 pi over 3, y'all, we're going to need to know our unit circle. So grab a unit circle. You're going to need it. Take a peek. And if we're looking at 4 pi over 3, that guy is in quadrant 3. That guy's in quadrant 3. Right? And the coordinate for that is negative 1/2 negative root 3 over 2. And we know that, of course, these xy coordinates go cosine, comma, sine. Cosine, comma, sine. So if I want to take sine of 4 pi over 3, that means we're going to look at the y coordinate. So this is negative root 3 over 2. And similarly, cosine is the y coordinate. So this is negative 1/2. Now tangent is y over x, so the y coordinate over x, or you could think of it as sine over cosine, but these are going to result in double-decker fractions. So you can also think of it as sine times 1 over cosine, or the reciprocal of cosine, which is what I'm going to do. So we're going to multiply it by sine, which again, sine was negative root 3 over 2. And we're going to multiply it. Instead of 1 over cosine, just think of it as like the reciprocal of cosine. So we're going to take not negative 1/2, but we're going to flip it. 2 over negative 1. These guys cancel, the negatives cancel, and you're left with the square root of 3. Fantastic. So what we're going to do in today's lesson is we are going to graph the sine function. All right. So get out your unit circles. Bust out a piece of paper if you haven't had one already, because we are going to just graph the sine function today. We're going to notice a bunch, and then we're going to talk about some new terms called period and amplitude. And yeah, let's get started, because I don't want this video to be a million years long. So why I love trig so much, and I know you guys know that I love it, and I'm so sad that I'm missing so much of it, is because it's literally so applicable. So see here in these images, like the way a tsunami and earthquake work together is there's obviously like a earthquake on the ocean floor. You can see right here where it has like a shift in the ground, and what that does is cause these crazy ripple effects, which leads to these massive huge waves on the beach surface. But you can see that it creates like these periodic, that's a really bad trace, but these periodic waves um, throughout, and that has an incredible force. We can even see here, this is a picture, this is like a physics picture of a spring with a weight on it. And so as that bounces up and down, we have these waves that come across. Even further, like how you're hearing the recording of my voice right now, right? As I speak, sound waves follow this type of like periodic um type of like wavelength, and of course it varies, but in general it works like this picture right here on the left, this is some macaroni. Okay, I went and had some macaroni at Bailey's in Old Town, and you can even see there's a little wave right here. Architecture, there's tons of waves. I actually saw a bunch in airports when I was in Madrid, and also when I was just like at Ontario International Airport to head to New York for my grandfather's funeral. Like there's literally so many trigonometric functions that are all over the place in architecture. Even like check out this crazy house. This is insane. That is going to be a function that we're going to graph. This slide, like are you kidding? And then if we were to unravel this Ferris wheel, like we just had Coachella, all right? Coachella just happened. I think both weekends, I don't know. And if we were to take this Ferris wheel and unravel it, it would look like this. And that's our sine and cosine graphs, which is incredible. One other huge application is the piston in an engine. The way that that goes actually ends up looking just like this graph right here, which is incredible. So they have a ton of applications in everyday life, which is just one of the many reasons why I love trig. Um, why I love these, what they're called is like periodic functions if they're repeating over and over again. Not only because it's like a fun puzzle piece to me, but also just because it has so many applications. So let's hop into it. Okay, so we are going to graph f of theta equals sine theta. We're going to graph the sine function. Now, we know how to find sine of a bunch of different values. We know how to evaluate, but do we know what the graph looks like? No, that's the goal of today. So recall that sine represents which value on the unit circle. Think back to our unit circle and we had x comma y. Which one of these, x or y, represented the value for sine, just like we did in our warm-up? It's going to be the y value. So sine represents the y value. Therefore, we can graph it by plotting the y value from our unit circle on this scale below. So you can see that this has like a million points on it. We start here at 0 and we end here at 2 pi. And if you look, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6 pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 11, 7 pi over 4, 11 pi over 6, 2 pi. All of those values are the radian measures on the unit circle, and that is not a mistake, okay? That was 100% on purpose. And then even further, if you look at the y-axis, right over here, right, we've got 1, we've got 1/2, we've got root 3 over 2, and we've got root 2 over 2. Okay, again, all of those were part of the coordinates when we were looking at our unit circle. So we're totally going to use that when we are graphing this. So let's start at 0, okay? And I'm just going to mark, I'm going to use, let's see, I'm feeling blue right now. We're going to start, and we're just going to start by evaluating sine of all of these values on our x-axis or a theta axis. So I really want to know, like, what is sine of 0? Sine of 0 radians, sine of 0 degrees, right? When we find that, we know, we look and that coordinate is 1, 0. Sine is the y, so that's going to be 0. Perfect. Then we want to evaluate sine of, pi over 6, right? So this one was 0. So sine of pi over 6, right? That coordinate is root 3 over 2, 1/2. So that means our y value is 1/2. So when x is pi over 6, y is 1/2. We're going to use that. Then we're going to move on to the next x value. Instead of this being pi over 6, we're going to change this to pi over 4. Pi over 4, remember, that's 45 degrees. That's root 2 over 2, root 2 over 2. So if we have pi over 4, that means we're going to have the value root 2 over 2. I do not know why it keeps erasing like that. Can we not? I'm using my stylus, so maybe it's just having trouble. I'm not sure. Then moving on to pi over 3. Okay, what is the y coordinate of pi over 3? That's root 3 over 2. Then pi over 2. X is 0. Y is 1. We're going to move up here to 1. Perfect. I don't know why it's erasing these. And you can see that we're kind of following that pattern. Okay? Now, 2 pi over 3. The y coordinate is root 3 over 2 again. So we're going to come back down right over here. The next one, 3 pi over 4. We're at root 2 over 2. Root 2 over 2. That is this point right here. 5 pi over 6. Negative root 3 over 2. Positive 1/2. So we're going to have 1/2. Ay, ay, ay. And you might be starting to notice the pattern by now. Now, when we finally get to pi, x is negative 1, y is 0. So we're going to go back down here to 0. Okay? We can start to see that the top half of this graph is going like this. Right? Now, I want you to make a prediction. What do you think is going to happen with the bottom half of the graph? What's going to happen on the bottom half? Well, let's take a look and find out. So next we need to move to 7 pi over 6. So looking at 7 pi over 6, on your unit circle, the y coordinate is negative 1/2. So that means we're going to have a dot right here. At 5 pi over 4, the next value on our unit circle, we have negative root 2 over 2, negative root 2 over 2. So we're going to have a point right there. At 4 pi over 3, our next y value is negative root 3 over 2. We're having a point right there. I don't know why these are erasing. And at 270 degrees or 3 pi over 2, we're at negative 1. All right? So we can kind of see what's happening here and continue on. 5 pi over 3. Now we're in quadrant 4. We're at negative root 3 over 2. 7 pi over 4. We're in quadrant 4 again. Negative root 2 over 2. 11 pi over 6. We're at negative 1/2. And 2 pi, we're back at 0. So completing our graph, we can see that our sine function looks like this. It starts at 0, it goes up and has a peak, comes back down at like pi, goes down and has a bottom peak, and ends at 2 pi. You need to know that this is what the sine graph is always going to look like. Your sine graph is always going to look something like this. Starts at 0, ends at 0. It goes up and then down. So I want you to look at this and get familiar with it. But we're actually going to see if we can simplify this because this is outrageous. Like, having all of these points on here is really, really crazy. So let's see if we can notice some things about it, make some observations, and make our lives a little bit easier. Instead of having to graph, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different points all the time. I think not. So here's our graph of sine again. So I want you to make a list of 5 or more things you notice about the graph of sine. Take a second and pause the video and make a list of 5 things. All right. So let's talk about it. So for starters, it always starts at 0 for like the y height. You could even say that it ends at 0 too. So it starts at 0 and ends at 0. That's one thing. Another thing you might notice is that it has its maximum peak and its minimum peak at 1 and -1. So it has a max at 1 and it has a minimum at -1. You might notice that it has like the middle of the graph is at pi, and that has a height of 0. Excuse me. And the last thing you might notice is that it finishes the graph at 2 pi. I mean, you also might notice that it looks like almost like a sideways S a little bit. That's usually something that people bring up. There's like 1, 2, 3, 4 equal parts is oftentimes what people bring up. And usually when we're looking at those 4 equal parts, a lot of times students notice that, like this is pi over 2, pi, 3 pi over 2, and 2 pi. And on the unit circle, those were all of the points. Like on the unit circle, when you have pi over 2, right, that's the coordinate 0, 1. At pi, that coordinate was -1, 0. At 3 pi over 2, that was 0, -1. And at 2 pi, that was 1, 0. Even here, starting at 0, that's 1, 0. And so a lot of times students start to put that together and they're like, hey, we really only need 4 points. Like at 0, we're plotting the height of 0. At pi over 2, we're plotting the height of 1. At pi, we're plotting the height of 0 again. At 3 pi over 2, we're plotting the height of -1. At 2 pi, we're plotting the height of 0. So a lot of times people add onto their list that we only need like 4 points to graph this entire thing. We just went from 16 down to 4. That is amazing. And we didn't even have to use like all of those crazy coordinates to do it. We really just needed these ones that are our quadrantal points, and it makes it so much easier to graph. You don't have to worry about where root 2 over 2 is, or like where rad 3 over 2 is. The only thing is like 1/2. We don't have to worry about all of that. The curve stays connected, but we needed that at first to kind of see what our graph was doing before we just jumped to conclusions. So make sure you guys have this list and anything else you might notice about the graph. Go ahead and jot that down too, because that's always the most interesting part. I'm really sad that I'm not here to like listen to your guys' discussion about this. This is one of my favorite parts of the lesson. So I want to show you guys a really cool sine graph animation. Check it out. We are going to bop over to this. And so right now we just see that this is going around in a circle and nothing's happening because I haven't turned it on at all. So it's just going around the unit circle as you would. You're kind of creating all of those like points and everything. But check it out. once I turn on the sine animation, with every rotation, this is kind of like I was telling you guys about the like unraveling the Ferris wheel at Coachella, and look, we just finished at 2 pi, and then it keeps going on. So the more we go around, even if we go past 360 degrees, the graph continues. And this is what I mean when I say periodic functions, is periodic functions are functions that continue to repeat over and over and over again. So we can see that our graph of sine continues in this fashion well after 2 pi. It just keeps going on however long you need to, which is really cool. So let's hop back into our lesson after a gross cough break. And so what I want to introduce to you is, since they're called periodic functions, there are things called the period and the amplitude. And these are just two ways we can describe what's happening to our function or what's happening to our graph. So we are going to introduce the equation y is equal to a times sine b of x. Okay, so I want you guys to write down this equation right here. A times sine of b of x. This is going to come in clutch. And first off, we're going to start talking about a. Okay, what is a? A is the height of the function from the midline. And if you're like, what the heck's a midline? Well, what do you think it is? It's the middle line of the graph. It really is just that straightforward. So if we're looking at this function right over here, we're looking at this guy, right? We've got this going. If you were to find the middle of this graph, like we could say 6 is the height and -2 is the min. So we could like find the middle. What's the middle distance between 6 and 2? 6 and -2. And we could see that our midline, our middle line, is going to be right here. See how it chops it completely in half, right? So this is the midline. Okay. And if I want to know that A is the height from the midline, right? That means I'm going to measure from here up to here. Like, how tall is this? From 2 to 6. What is that? 3, 4, 5. Oh, that's going to be 4. Or you could think of it as from the midline to the minimum. So from 2 to -2, well, that distance is also going to be 4. So the amplitude, or the A value of the function, is the vertical height of the graph measured from the midline to the max or from the midline to the minimum. So that's what amplitude is. It's not the total distance from max to min. It's from the middle of our graph to the top or from the middle of the graph to the bottom, whatever is easier for you to visualize. For me personally, I like to usually work on the top half, but whatever works best for your brain. The amplitude, it's going to be represented by this letter A in front here. It just represents the height of the function from the middle of it. So here are 3 graphs, okay? We're going to identify the amplitude of the graphs below. And then I want you guys to sketch the distance from the midline so that we can visualize this amplitude height. Because remember, the amplitude is from the midline. So here is these graphs, all right? We've got a crazy one to start us off. And the maximum height is 2. The minimum height is -2. So this one's kind of easy. Our midline, our midline is right here, right smack dab in the middle. There's our midline. And now we can see clearly that, like, yeah, from here to here, that's going to be my amplitude. Or similarly, from here to here, that's my amplitude. This has an overall distance of 2, and this has a distance of 2. So my amplitude is equal to 2. And since this is the sine graph, and I've only asked you this, our equation would be 2 sine of x. Because amplitude, the letter A, was in front of sine. Look back at this. It's right in front of sine. I haven't discussed what B is yet, but we're just focusing on A. So let's do it again for the next graph. We've got kind of another crazy one. Let's check it out. Let's see, what is our maximum height? We've got this value right here, which is in between 2 and 4, so that's a 3. And if I go and find the minimum, that's right here as well, and that looks to be -3. So the middle of +3, -3, again, that's going to be right here at 0. So this is our midline, and obviously we can kind of do the same thing from here to here. That's a height of 3. Or from here to here, that also has a distance of 3. So our amplitude is equal to 3. If we were going to write an equation for this function, we might say that this is equal to 3 times sine of x. Because again, all we've discussed is amplitude so far. Now let's do our last one. Let's take a look here. And we need to identify the midline. So even without looking at the max and min, you can kind of eyeball it. You can see like, yep, right there looks to be about the middle. Let's see where this seems to be my max. This seems to be my min. What are these heights? If this is 0 and this is 2, this looks like it's 1 and -1. And you don't even have to do this visual that I keep doing, but like from here to here, that has a distance of 1. From here to here, that has a distance of 1. So obviously our amplitude is just equal to 1. This is actually normally what our sine graph looks like. So we might say that our function is just y is equal to 1 times sine of x, or just sine of x. Don't necessarily have to have the 1 there. Okay. Next, we need to talk about period. Okay, so we can discuss the amplitude and the period when discussing these periodic functions. And since they're periodic, meaning like they repeat over and over again, a period is how long it takes to finish one cycle of the graph. So if we're looking to figure out how long it takes one cycle, we're literally just going to visualize, look at the x-axis, and see where does it start and where does it end our sine graph. Now remember, I told y'all we're going to need to know that sine looks like this. Starts at 0, and it goes up, comes to 0 in the middle, goes down, and ends at 0. So we're literally just going to highlight pieces of this and ask ourselves, like, what is the horizontal distance of this cycle? How long does it take? What is the horizontal distance? Notice on the last time we were doing amplitude, when we were looking at our amplitude, that was like our vertical distance right here. That was our amplitude. Now, our period is the length of this wavelength. How long does it take? And now we're like, okay, I want to know what this distance is. How long does it take to do one cycle of the sine graph? Because in a periodic function, it's going to continue to repeat itself over and over and over again. So a period is how long it takes to finish one cycle of the sine graph. Let's get into some examples. Okay, so again, here's these are the exact same graphs we just saw. All right, they're starting off a little crazy. So this time we're looking to figure out where the period is. So the way I like to facilitate this is I want you to sketch the period on top of the graph. So grab a highlighter, grab something, and I want you guys, like, not just a pencil, like something where you can actually see the one cycle of sine. just like I'm about to do on the screen here. So first things first, sine always starts at 0 and ends at 0. That was one of our noticings. So here we're going to start at 0. And we're going to go up 1, back to 0, down 1, and end. This right here is one cycle of sine. So my question is, how long is this distance? How long is that? Well, it doesn't have a label, which kind of sucks. Usually you would just look. You would just take a second and look right here, and you'd be like, okay, what is this value? Look right on the x-axis. But right now it does not say anything. However, if we look a little bit further, this guy's labeled. That's a terrible color. But this guy's labeled. Right over here, this is pi. And it completes a second round, right? If it keeps going, pi. So if there's 2 rounds in pi, this guy excuse me, is half of that distance. And pi cut in half would be this value right here, pi over 2. So here, the period, the length of that one cycle of sine is pi over 2. Let's do the next example, okay? So again, I want you to highlight what is the one cycle of sine. Starts at 0 and has to end at 0. Now, it's not just up and down. That's half a sine. We have to go up and then we have to go down as well. So I want to know how long, what is this distance? And you usually, like I said earlier, you just look at the x-axis. So look right here. That says 2 pi. So the period length on this graph is 2 pi. I'm going to use p to represent period. And lastly, we want to check out this other graph right here. All right. Again, highlight one cycle of sine. Starts at 0 and ends at 0. Starts, goes up, comes back down to the middle, goes down, and comes back, right? The period is how long is this wavelength? How long does this wave last for? And again, you can always, pretty much always, just look at where it ends and look at the x-axis. And that's going to tell you that distance, right? 4 pi. So here the period is 4 pi. For this other one, it's stretched out a little bit longer. It only does half of the graph from 0 to 2 pi. And if for some reason on the x-axis, like it's not labeled, like over here it wasn't labeled, look over and find the next label and see if you can figure out, like, is it half that distance? Is it a quarter? Is it a third? Like what is exactly happening with that? This one, we were lucky enough where it was half of the distance of the next marker. So it was half of pi, or pi divided by 2. So notice for this equation, I thought that was going to be a highlighter. For, excuse me, disgusting. A times sine bx. There's not a letter for p in there. There's no letter for the period. Okay? There's a for the amplitude, but there's not p. So the question is, what in the heck is b representing? What does b mean? And so I want you guys to write down that b is the number of cycles that occurs in 2 pi, or the number of cycles that occurs in 360 degrees. So how many cycles of sine are going to happen in 2 pi radians or 360 degrees? So B is a numerical value that represents how many cycles of sine is completed in 2 pi. It has to be completed cycles. It also can be used to find the period length if it's not easy to tell. So period and the letter B kind of represent the same thing. Okay, so I also want you to write down this formula. P is equal to 2 pi over B, where B really just represents the frequency, how many cycles are finishing in 2 pi. So P represents period, so the period is equal to 2 pi over B. But if we solved that equation, right, if we solved that equation, P equals 2 pi over B, for B, right, multiply this by B, multiply this by B. Now I have B times P equals 2 pi. Oh, but I want B alone this time. So divide both sides by P. You end up getting B equals 2 pi over P. This is almost the exact same equation as this. So you know what? Just write them both down. Depending on what you're looking for, like, you can use either equation. If you want to verify the period, we can plug in the number of cycles that are completed in 2 pi into an equation. Or vice versa. If we have the period is given to us, we can determine the value of B, which goes into our equation, right? Like for this equation, B is right here. So we can use either of these to help us find the number of cycles that occur in 2 pi. And for this, again, we're also really going to need to pay close attention to the x-axis, all right? To the x-axis. So P equals 2 pi over B, or B equals 2 pi over P. 2 pi is always in the top, and B and P are across from each other. They're interchangeable almost. So our goal right now is to identify the number of cycles in 2 pi. Number of cycles in 2 pi, we're identifying B right now. How many cycles of the sine graph is in 2 pi? So in order to do this, we need to find where 2 pi is on our graph. Where is 2 pi? Notice that over here, here's 2 pi, right? On this graph, here's 2 pi. On the next graph, here is 2 pi. That's important. That tells us how many completed cycles of sine have occurred from 0 to 2 pi. We need to know that. We're literally just going to count. So on our first graph here, we can see there's obviously a bunch. There's more than one, that's for sure. So we're going to start at 0. And here is one cycle of sine. That's 1. Then we're going to move on to the next cycle of sine. There's 2. Then we're going to move to the next cycle of sine. Right there, that's my third cycle of sine. And then the next one, which starts right here, 0, and ends at 0. We can visually see 1, 2, 3, 4 cycles of sine from 0 to 2 pi. So since we can see that there's 4 cycles from 0 to 2 pi, that means B is going to equal 4. B is going to equal 4. And I wanted to show you, remember that B is equal to 2 pi over P, right? And we can see that the period length, that's this distance. Remember, that was pi over 2 from last time. We could plug that in, right? We would say that that's going to be 2 pi over 2. Ew, gross, double-decker fraction. Keep, change, flip. Keep 2 pi. Change it from division to multiplication and flip it to 2 over pi. Oops. These pi's cancel. 2 times 2, would you look at that? Gave us 4. Look at how many we counted. 1, 2, 3, 4. So the formula works. The formula works. Or we could have worked backwards and found out the period length too. We could have said, not only does B equal 2 pi over P, but we could have switched this up. If you need that again, just rewind the video a little bit. P is equal to 2 pi over B. So since we have b is 4, we could have found out that the period was 2 pi over 4, and 2 over 4 reduces to 1/2. And so that gave the period of pi over 2. And again, we can see this distance was pi over 2 because it was half of pi. So they both make sense. Let's go to the next graph. Let's see how many cycles are from 0 to 2 pi of this graph. How many cycles from 0 to 2 pi exist? So start at 0, end at 2 pi. I already did a little marker. Has to go up, down, and then end at 0 again. Here, there's only one cycle. So b is equal to 1. And again, you could use this information to find what the period is, right? That's going to be 2 pi over b. The period is 2 pi. How long does it take to finish one cycle? Well, yeah, that is exactly 2 pi. So things check out. Or since the period is 2 pi, you could have figured out what b was. That's 2 pi over the period. That would have been 2 pi over 2 pi. And yeah, that equals 1, which is exactly what we saw. And the next one, we want to know how many cycles of pi is from 0 to 2 pi. I have to stop right here. That's not a full cycle of sine, right? Because we have to go from 0 to 2 pi. So that's not all of it. My sine graph continues all the way over here. It finishes at 4 pi. So how do you think we would describe how many cycles of sine were from 0 to 2 pi? It's not a whole one, but instead, exactly, it's half. Half. And again, we could use the fact that b is equal to 2 pi over the period to verify this. We can tell that the wavelength of sine in this particular graph, the wavelength, that's 4 pi, right? That's p. That's what p represents. So this really means that we've got 2 pi over 4 pi. Pi's cancel. 2 divided by 4, well, would you look at that? It gives you 1/2, and that is exactly what we found. There's only half of the sine graph between 0 and 2 pi. And so B represents the number of cycles in 2 pi. The number of cycles. So one other thing that I want to add really quickly to each of these is what the equation would be for this if we're going to use A times sine times B. So I'm just going to do this really quickly, probably in like this purple color. So this guy has an amplitude of 2. So amplitude of 2 means 2 goes in front. Then the trig function sine, and then B. Since we said this was 4, there was 4 sines in 2 pi, we're going to have 2 sine 4x. That's what we have for B. The next graph, we have the amplitude, the middle, this height, this looks to be from 0 to 3, and this is from 0 to -3. Yes, so our amplitude here is 3. So we're going to have 3 sine, and then how many B's, how many cycles fit within 2 pi? That was just 1. So this would be 3 times sine of 1x, or just 3 times sine of x for that equation. This last one, it looks like the middle is here. This has a height of, it's between 0 and 2, so 1. So that means our amplitude is equal to 1 sine. And remember, our B value for this one was 1/2. So we're going to have 1/2 after the sine, but before the x. So that last graph was 1 times sine of 1/2 x, or just sine 1/2 x. So now we're going to combine all three skills. Given these graphs, we're going to identify the amplitude from the middle to the max, or the middle to the min. The period, how long does it take to finish sine graph, and B, number of cycles in 2 pi, and then determine the equation. So all three of these things is going to help us build up and create an equation. That looks like this equation. Kind of like what I was just showing you. So let's take a look. Let's find out our amplitude, okay? So from this graph, it looks like the midline, is right there. If that's 0, this looks to be 1, 2, 3. That's 3. And let's check from here. Here's the bottom. That looks to be 1, 2, 3 as well. So our amplitude is 3. The period is how long it takes to complete one cycle of sine. So start at 0 and finish. And we finish our cycle of sine at pi. That's our period length. Excuse me. Then it asks us to count the number of cycles from 0 to 2 pi. So there's one sine. We can pick it up. Here's a second one. There's 2. And so if we were going to come up with our equation, we would say that y is equal to 3. That's the amplitude A. This is the sine graph. We're putting our trig function in there. And then the number of cycles, this is B, is 2. And you can put parentheses right next to it. A lot of times people will put parentheses here. Some will put them here. Some won't put any at all. So I'm going to leave it. Honestly, I think I'm going to do it with no parentheses at all. Just know that B comes after sine. And let's practice for the next one, okay? So take a second and figure out, what is the amplitude? What's the amplitude of this second graph? From the middle to the max, or the middle to the min. Here's the middle, it looks like. Here's the middle. And we go up here, so that's 1, 2. Here's the middle, goes down here to -2. So our amplitude is 2. This distance is 2, and this distance is 2 from the middle. Period. How long does it take to complete one cycle of sine? How long does it take? Look at the x-axis. This one's a little off, but since 2 pi is right here in the middle, that's definitely, that 4 pi should have been a little closer. So the period length, how long it takes to finish one cycle of pi, is one cycle of sine is 4 pi. And then if we're trying to figure out how many cycles is from 0 to 2 pi, here's 0, here's 2 pi. Well, there's only half. That's only half of my graph. So that value is 1/2. And remember, that's B. That's our B value. So if we're going to come up with an equation, we're going to say y is equal to 2, our amplitude. Write in our trig function. This is sine. This is the only one we know so far. And then B, how many cycles? 1/2. Don't forget the variable x. Sometimes instead of x, we'll use theta. Sometimes they use the variable t for time. Whatever the variable is, that has to come next. All right, let's keep chugging along. Given an equation now, we're going to identify period, amplitude, and probably confirm some values of B. So just for fun, it's not asking for that, but we might as well strengthen our understanding. So period is how long it takes to complete one cycle of sine. Amplitude is the distance from the middle to the top, or the middle to the bottom. And B is the number of cycles from 0 to 2 pi. So first things first, we are looking at this equation. We have, 3 times sine of x. So a lot of times, honestly, with these, you just look at the equation. We've got 3 in the A position, so the amplitude must be 3. Let's look at the next equation. A comes before sine, so our amplitude is 4. A comes before sine, there's nothing there, so we're going to say it's an invisible 1. And the last equation, A comes before sine, we're going to say it's 5. I'll describe what the negative means in just a minute, but if we're just looking for amplitude, remember, amplitude is describing the distance from the middle to the max, or the distance from the middle to the max, or the middle to the min. And distance is never negative. So we always said, like, oh, this was 3 and this was 3. They're always 3. It's just this is 3 going in the positive direction and this is 3 going in the negative direction. But just like your odometer doesn't go negative when you turn around and go home at the end of the day, distance is never negative. So amplitude is always going to be a positive value. Now, we have to determine the period, which is how long does it take to go and finish one cycle of sine. Now, remember that sine graph looks like this. Starts at 0 and it ends at 0, okay? So again, the period is this length. How long does it take to start and end our cycle of sine? Now, it does not give us, P is not a part of our equation at all, but B is. B is a part of our equation. It's in front of the x. So we got to look for our B value. And this is going to help us solve, because although we don't have P as a part of the equation, we know that it's related to the period because it's 2 pi over the B value. Period is equal to 2 pi over B. So let's go ahead and solve all of these. All right. So if we want to find P, it's going to be equal to 2 pi over B. And in this first equation, there's no number in front of x, so B is equal to 1. So P is equal to 2 pi over 1, or that's just going to give us P. I wonder why it's doing that. Excuse me. Weird. P is equal to 2 pi for this first one. 2 pi. This 2 pi over 1 simplified to 2 pi. Let's do the next one. So P again is equal to 2 pi over the B value. We can see here that B was 2. So that's 2 pi over 2. Those 2's are going to cancel. So our period length is just going to be pi. So when it finishes from start to finish, that's pi units. That's all that means. Let's do the next one, okay? Period is equal to 2 pi over B. We can see that B is right here. That's 2/3. Ew, double deckers. We don't like it. So we're going to keep the numerator, change it from division, and turn it into, and then keep, change, and flip the denominator fraction. So that means 3 is going to go on top. 2 is going to go on the bottom. This 2 cross cancels with that 2. P is equal to pi times 3, or we could call that 3 pi. Again, so this distance for that graph means it's 3 pi instead of just pi. And our last equation, right? We've got P is equal to 2 pi over the B value, which just represents how many cycles of sine is in 0 to 2 pi. And the B value is found right in front of the x in our equation, right after sine and right before x. So we get to substitute in, this is 2 pi over 6. Pi's don't cancel, but 2 over 6, that reduces to 1 over 3. So our period is pi over 3. Again, when we go from 0 to when we start our sine function and end our sine function, all we're saying is the period is that horizontal distance is pi over 3 units. Take a second. Hoping this is starting to make sense. I know it's a lot at first, but I think it's pretty good. All right. Now we're going to sketch the graph of one cycle of each function. Okay? So I'm going to give you an equation. Heck, I'm even giving you the period and amplitude for them. And when we're sketching the graph, we're really sketching it, okay? What's important about this sketch is the labels. You're absolutely going to have to label the x-axis, and you're absolutely going to need to label the y-axis. The sketch can be as simple as us doing this, right? Start at 0 and end, but you have to label. You can't just leave it like this. You leave it like this, you're not getting any points, okay? I'll be like, woohoo, good for you. You can graph sine. But this, the most important part, if we're going to sketch a graph, we need to be accurate as possible. So you're going to have to tell us what's on the x-axis and what's on the y-axis based on the information given. Okay, so we want to do one cycle, just one. I don't need to repeat it over and over and over for right now. We're just learning sine. But I want to graph sine, my sine function. And for the very first one, we're given that the amplitude is 4. So the amplitude is 4. That's this value right here. The amplitude is 4, which means from the middle to the max has a distance of 4, and from the middle to the minimum has a distance of 4 as well. So honestly, you can take that information and label the y-axis, because remember, amplitude is measuring like that. Like how big is that distance? And we know that distance is 4. So we can just mark this as positive 4 and then negative 4. That's as easy as it has to be. Fantastic. So we've got our amplitude. Now we have to sketch the entire one cycle of the sine function. And the period is this distance. Period is how long does it take to finish. It's that horizontal distance. So we're saying that is pi. So how we're going to use this information is to to mark the furthest right value on our x-axis, right? That is always going to be the period. Whatever the period is, that's the value that we're going to put right here. Whatever the period is, that's what we're going to put right there. But remember when we were graphing sine, it started like at 0 and then it went up to the maximum value, right? And then it would come back down and then it would go to the minimum value and then it would have to come back to 0, right? So in that, we're going to need 4 even chunks as well. We're going to need 4 even pieces. So since we have that this one, I'm just going to move my label a little bit here. Since we have that this value, this value right here is pi, that was our period, right? We're going to need to label all of these. And so usually I don't even graph the graph yet. I start off with pi over here. Not a highlighter. I start off with whatever the period length is pi, and I know I need to split it into 4 parts. So I just do fractions. So I start off one whole piece is pi, half of that, whatever that value is, cut it in half. So we've got pi over 2. Then I need, I've got 2 parts, I need 4 total. I cut these in half again. So if I cut pi over 2 in half, that's going to give me pi over 4. You really just multiply the denominator, like this denominator, by 2 when you're dividing it in half. So 2 times 2 gives you 4. Now, here's the trickiest part. Okay, and I want you guys to really stick with me for this one, okay? This is 1 pi over 4. The next one is 2 pi over 4. And that fraction reduced to pi over 2. What would the next one be? It's kind of like how we constructed the unit circle. If we had 1 pi over 4, 2 pi over 4, this next one would be 3 pi over 4. That one doesn't reduce at all. And then lastly, just pi. And once you have your x-axis labeled, then you can go in and graph your sine function. Starting at 0, at that first one, it's going to go up to the top. At your second one, it's going to come back down to 0. At the third one, it's going to go to your minimum value. And at the last one, it's going to end at 0. And then your graph is going to look a little something like this. Okay? So with the sketch, you have to label the x and the y-axis. Amplitude is the is the y-axis. Period is the x-axis. Let's try it again with this next graph. Ooh, this one has a negative. I forgot to talk about what the negative looked like, so I guess I'll talk about it now. Let's start with what we know. Let's start with the amplitude, okay? So amplitude is distance, amplitude is 5. Remember, that is starting from the middle all the way up, or from the middle down to the bottom. So we said that that is going to be 5. So let's automatically label our y-axis right now. So the maximum height that our graph is going to have is 5 and negative 5. Now, this negative right here, that means it's going to be a reflection. And we've always talked about reflections this year, and it's always been across the x-axis. So I want to show you a reflection on the top graph that we have. Right up here with the black graph that we already have established. So if you were going to reflect this point, if you were going to reflect this point across the axis, it's going to stay right there. It's not going to move. Okay? However, if you're going to take this point and reflect it across the x-axis, across this dashed line, that means that point is going to go to the bottom. If you're going to take this point and reflect it, you can't reflect it across. It's right at 0. Now at 3 pi over 4, when you're going to take this and reflect it, that means it's going to pop up and the last point is going to stay. So notice that our regular sine graph goes like this. That's just positive sine x. When you have a reflection, instead of starting and going up, you instead do the opposite. So negative sine x is where you start at 0 and you end at 0 still, but you go down and then up. You go down and then up. So that's what we're going to have in this graph. We're going to have a reflection right there. Now, before I can add in that reflection, though, I need to have my x-axis labeled. So that means that we are going to need to account for the period. The period length says that it's pi over 3. And again, we're going to start by just labeling all the way down here pi over 3. Whatever the period is, that's going to be the farthest right on the x-axis. Then we're going to cut it into 4 equal parts. Start by dividing it in half. Pi over 3 divided by 2. You're going to multiply the denominator by 2. That becomes pi over 6. If we cut it in half again, pi over 6 divided by 2 more, take the denominator and multiply it by 2. This becomes pi over 12. And then the trickiest part here is to get this third one, you have to count by how many of these you have. So this is 1 pi over 12. This is 2 pi over 12. This next one would be 3 pi over 12. But that is reducible, right? Notice 3 and 12, those are reducible. So 3 goes into 3 one time. 3 goes into 12 4 times. So this guy is actually pi over 4, which is kind of crazy. But whenever you have this first one again, you just count by that. 1, 2, 3, reduce if you can. Once we have all of our x and y axes labeled, then you get to draw on your graph. And remember, it always starts at 0 and ends at 0. And heck, even in the middle, it's going to go to 0 as well. So you can always start by graphing it like this. Remember, if it was regular sine x, it would start from here, go up, and come down. But we do not have that. On this graph, we have a reflection, which means instead, it's going to start at 0, but go down, come back up, and then reach its peak and come back down. So that's what happens if you have negative in front of your amplitude. You reflect. Okay. We're almost done, I promise. I know this has been heavy. Select the equation that represents the graph below. Okay, so we've got A, B, C, D. We've got cosine, sine, sine, sine. If we're looking at these, we've really only discussed sine. So automatically, when this says cosine, out of here. We don't even know what cosine looks like. So why would I ask you that? So we've got sine, sine, sine. And now we've got to determine the amplitude. Is it 3? Or is it 6? And remember, the amplitude is this distance. So let's see what this looks like. This has a maximum of 3 and a minimum of -3. So yeah, the amplitude is definitely 3, which means we can eliminate this last one. Now we just have to decide if B, the B value, is pi over 2 or pi. So we need to know what is B to make this final decision. And remember, we had a cool formula. We said B, no, I want to use a different color. B is equal to 2 pi over P, the period. And the period is how long it takes to finish one cycle of sine. So let's see, how long does it take? Here's one cycle of sine. Oh, look, right there. P is equal to 4. So let's plug that in. If we plug that into our equation, this is 2 pi over 4, and that's going to reduce to pi over 2. Since it's pi over 2, that means C is our equation. Here's another one, okay? Identify the amplitude and period and then sketch the graph. Okay, so we've got 4 times sine of pi x. Automatically, amplitude's right here. Amplitude is 4. The maximum height is 4. The minimum height is 4. So we know that the max is here at 4 and the minimum is here at 4. You can even kind of like put these horizontal lines like I'm doing as like don't cross these lines. That's as high as it can go and as low as it can go. Now to find the period is equal to 2 pi over b. And we know b. The equation gives us b. It doesn't give us the period, but it gives us b. So we could plug that in. All right, so this means we're going to have 2 pi over pi. Hey, that simplifies. Our period, therefore, is going to be 2. So remember, the reason why we care about the period is that's the length. The length of our curve. So that means we have to finish our entire graph of one cycle of sine from 0 to 2. We have to finish our graph from 0 to 2, which means we're going to have a middle point, and our maximum value is going to be in the middle of that. So it's going to go all the way up to 4 in the middle, between 0 and 1, and then again in the middle between 1 and 2, like this. And so our graph looks like this. And I could continue a second one if I wanted to. It would go here, here, here. Again, up to our max, down to the middle, down to the min, and finish. And keep going on. But usually I just want one cycle. That one was kind of tricky, kind of hard. Okay, and lastly, graph these sine curves. What is the graph of one cycle of sine with an amplitude of 2, period of 6 pi, midline 0, and a is greater than 1? What is this sine curve? So we automatically can start picking out information from this. It says it's going to have an amplitude of 2, which means the max and the minimum value are going to be positive 2 and negative 2. And our equation is already going to start with y is equal to 2. Okay? If we have a period of 6 pi, remember the period was this length, 6 pi, but the period is not a part of the equation. B is. So we need to solve for b, right? So b is equal to 2 pi over the period. So 2 pi over, we're given the period is 6 pi. Pi's cancel. 2 over 6 reduces to 1/3. So that means we're going to have 2 times sine of 1/3 and then our variable x. Boom. Fantastic. Now, if we're actually going to graph this, remember our period said it was 6 pi, so that is the furthest right x value. We need 4 equal pieces. 6 pi cut in half, that's 3 pi. 3 pi cut in half, I'm just going to say 3 pi over 2. It's a little weird, but we'll just leave it as 3 pi over 2. And we're going to count. So this is 3 pi over 2. This would be 6 pi over 2. This would be, the next one would be 9 pi over 2 from here to here. And then 10, 11, 12 pi over 2 to get that last piece. And after we have all of that, we can finally graph our function. It's going to start at 0. It's going to go up to our maximum value of 2, down to 0, down to our minimum value of negative 2, and back to 0. And we have a is greater than 1, meaning that there's no no reflection across the x-axis. Let's do the next one. Okay, so what is the graph of one cycle of sine? If it has an amplitude of 1/2, meaning our max and our min value is going to be positive 1/2 and negative 1/2, and our equation is going to have 1/2 in it. So y equals 1/2 and then sine. since it said we're graphing a sine graph. We are given here in this example that the period is 4 pi. Remember, this distance is 4 pi. So we're going to need to find b. Again, b is equal to 2 pi over p. Our period we just said was 4 pi, so that's 2 pi over 4 pi. Pi's cancel. 2 over 4 reduces to 1/2. So we're going to have 1/2 in there. We're also going to have our variable x. Midline is at the center, so that's fine. But this last example says that a is going to be less than 0. That means we have a reflection. So instead of our regular one, we're going to start at 0 and end at 0, and we're going to go downwards, actually. Our graph is going to look like this. So let's label. We have our y-axis labeled, and if our period is 4 pi, that means that's this value all the way over here. Halfway is 4 pi cut in half. That gives us 2 pi. 2 pi cut in half, that's just 1 pi. And now we're going to count. This is 1 pi. This is 2 pi. This next one will be 3 pi. Then again, you count and you have 4 pi. And our graph, I kind of already have like a little bit of a sketch there. But you can see that our graph, if it's going to have a less than 1, that means that it is going to be reflected across the x-axis. So we're going to go down here. We're going to come back to 0. We're going to go up to 1/2 and back down to 0. And so this is what our graph looks like for this one. Awesome sauce. Thank you so much for following along. If you needed to rewatch this lesson, please feel free to do so. It's going to be posted just on YouTube for you guys to watch along and do all of the great things. So thank you so much, and I will be back with another video in our next lesson.